84, we'll use the letter U. And we will use your calculator. We're going to learn how to enter all this in your calculator. Now, you'll notice something. N can never, ever be negative because the first term, in this particular case, is 1. So in this particular case, we will always allow, we have to use n is greater than 2. Because we already defined use of 1. We already said we have n1. So the next term will be n2, n3, n4, n5, and so forth. Again, we don't have any negative integers for our term number. We can't have a negative term. Okay? So I want to remind you again, the use of 1 equals versus the un equals to un minus 1 plus or minus something is a mere notation for recursive formula. All right, so let's move to the next slide and let's see if we can do this part. So here's some more example. Suppose we have a concert hall that has 59 seats in row 1, 63 seats in row 2, 67 seats in row 3, and so forth. The concert hall has 35 rows of seats. Write a recursive formula to find the number of seats in each row and how many seats are in row 4, and then tell me which row has 95 seats. I'm going to suggest you pause right now and try this example, and then I'm going to show you the solution and see if what you wrote versus what I wrote is actually the same. So here's my understanding. So we have the start, of 59, and I realized that it's actually harder to write on my computer than anything else. So, and then to get the next number, we will add 4, all right? So again, I don't want to write the word start equals 59 every single time. I don't want to write to get the next row, add 4 to it. So mathematically, here's the notation. U1 will be 59. UN equals un minus 1 plus 4. And my term numbers, since we already have the first term, we can use this recursive formula to find the second term, the third term, any terms that is beyond 1. So this is now the complete recursive formula for this example. I do want you to know as I'm teaching and recording this, I am drinking water, and so you will hear me swallow water at any given point. So, all right, so that's the recursive formula. It has 2 things. It has the starting values, and it has what do we do next, how to get the next number, and that is we add 4 to it. All right? So now let's answer the next set of questions. How many seats are in row 4? Well, in row 1, we have 59. In row 2, we have 63. In row 3, we have 67. So in row 4, we will have 71. Row 5, we will have 75. Row 6 will have 79. Row 7, we will have 83. Row 8, we will have 87. Row 9, we're going have 91. And then row 10, we're going to have 95. So to answer the next set of questions, how many seats are in row 4? Well, there are 71 seats. Which row has 95 seats? There are 10. Row 10. All right, so let's move on to the next set of definitions. So the two examples that we did earlier, they're called arithmetic sequence. Okay, that's a vocab that you should know. You should write that down. And the terms of the sequence are related by what we call a common difference. All right. By definition, here's the definition. Arithmetic sequence is a sequence in which each term is equal to the previous term plus a constant. So we're adding something. In some cases, you could be subtracting a constant. So I'm a little flexible on that. This constant or this number is called the common difference. Okay? And it's usually denoted by the letter D. All right? So here's what we have. The recursive rule for the sequence, this is specifically arithmetic sequence, it has this form. U1 or 0. Okay, we will talk about, well, when do we use U sub 0? Okay, but we need a starting value, all right? So U1 or U sub 0, that's our starting value. And then the formula is UN equals to UN minus 1. We either adding or subtracting. Now, most of the time, I think you can see the pattern. If you cannot, okay, if you're looking for D, if you're looking for the common difference in an arithmetic sequence, you can always take the second term minus the first term. Okay, so for example, the concert hall earlier. I can take 63 minus 59 and get that the common difference is 4. All right, so that's what we call an arithmetic sequence. Now, another sequence that we need to know is what we call a geometric sequence. All right, and there's a link to the Sierpinski's triangle on the web. Now, I'm not going to click on that right now, but if you go to Google and type in Sierpinski's triangle, you will know exactly what I'm talking about.